Hi, in this video, we are going to look at word equations. A word equation is an equation written as an actual sentence. To tackle word equations, we need to turn the sentence into an algebraic equation that we can solve. Now, a good place to start is to read through the whole problem and decide not only what we need to find, but what information has already been given to us. You need to consider the words used in the questions, as these will tell you what you need to do. If you see add, sum, more than, or increase by, you know you need to add. Minus, less than, difference, and decrease tells us we need to subtract. If you see times, product, or factor, you need to multiply. And if you see quotient or out of, then we need to divide. The values we need to find are unknown. So to create an equation, we can assign them a variable such as x. Let's look at some examples. I think of a number, add 4, and the answer is 7. What is the number? The number is our unknown value. This is what we need to find. So let's for now call our number x. I think of a number and I add 4. So to x, we're going to add 4. And our answer is 7, to make our equation equal to 7. X is our unknown number, so now we can solve for x. Let's move this 4 across, and we say x is equal to 7 minus 4. And we see that x is equal to 3. 3 is our unknown number. Let's do another one. A rectangular garden is 12 meters by 5 meters. What is its area? The first thing we need to focus on is area. The area of a rectangle is found by multiplying the length times the breadth. Length is greater than breadth. So in this case, we can say the length is 12. So I can say L will be equal to 12. And the breadth is 5. So I can say B is equal to 5. And now I can write my equation. So for area, I'm going to say A is equal to L, which I know is 12, multiplied by B, which I know is 5. 12 multiplied by 5 is 60. So the area of the garden will be equal to 60. Sam and Alex played tennis. On the weekend, Sam played 4 more games than Alex did, and together they played 12 games. How many games did Alex play? The first thing we need to do is to assign values to Sam and to Alex. Let's make Sam equal to S and A for Alex. The question tells us Sam played 4 more games than Alex. This means that if S is Sam, the amount of games is Alex's games plus 4. Together, they played 12 games. So if we take all of Sam's games and we add all of Alex's games, we have an answer of 12. How many games did Alex play? We need to solve for A. And now we've got 2 simultaneous equations. On this side, S is the subject, and it's equal to A plus 4. So in our second equation, instead of writing S, we're going to write A plus 4. Then we add A, and we make this equal to 12. And now we can solve for A. A plus A is 2A is equal to 12. I'm going to minus this 4, so we say minus 4. 2A is equal to 12 minus 4, which is 8, which means that A is equal to 4. And Alex played 4 games. Let's do another one. My mother was 26 years old when I was born. She is presently 3 times as old as I am. What are our present ages. We need to find both my age and my mother's age. So let's start by assigning values. Let's say that my age is X and my mother's age is M. The question tells us my mother was 26 years old when I was born. So that makes my mother 26 years older than me. So my mother's age will be equal to my age plus 26 years. At the moment, presently, she is 3 times as old as I am. So if my age is X, then my mother's age is equal to 3 times that much, which gives us 3x. And again, we have simultaneous equations that we can use to solve for m and for x. Here we see that m is equal to 3x and m is equal to x plus 26. So if m is equal to 3x, I can say 3x is equal to x plus 26. And I can use this equation to solve for x. So let's move this x across and we get 3x minus x is equal to 26. 3x minus x is 2x equal to 26. Divide both sides by 2 and we see that x is equal to 13. Now that I have my age, let's find my mother's age. So we can say m is equal to x is 13, so I'm going to say 13 plus 26, which means that my mother's age is 39. And we have now solved for x and for m. Let's look at some examples that are a little bit more intricate. A shop sells bicycles and tricycles. In total, there are 7 cycles. Cycles include both bicycles and tricycles, and 19 wheels. Determine how many of each there are if a bicycle has 2 wheels and a tricycle has 3 wheels. Now we are looking at bicycles and tricycles. So let's start by assigning these values. Let's call bicycles B and tricycles T. The question also tells us that we need to consider the wheels of both of these cycles. The question tells us that every bicycle has 2 wheels. So for every bicycle we will have double that amount in wheels. So we can say B wheels is equal to 2B. Tricycles have got 3 wheels. So for every tricycle, we will have 3 times as many wheels. So we can say T wheels, T for tricycle, is equal to 3T. Now let's look at the question again. In total, there are 7 cycles. So if we take all of the bicycles and we add all of the tricycles, we'll have a total of 7. There are a total of 19 wheels. So if we take all of the bicycle wheels and we add all of the tricycle wheels, we'll have a total of 19. And now again, we have simultaneous equations. And we're going to use these 2 equations to find out how many bicycles we have and how many tricycles we have. Let's start by making B the subject of this equation. So I can say B is equal to 7 minus T. And now I'm going to substitute 7 minus T into our B value over here. So we say 2, open bracket, 7 minus T. Then we have plus 3T is equal to 19. And now I can expand the bracket. So we say 2 multiplied by 7, which gives me 14. 2 multiplied by negative t is negative 2t. Then we have plus 3t is equal to 19. Negative 2 plus 3 gives us 1. So on this side we have t is equal to 19. Move this 14 across and we say minus 14. And we see that t is equal to 19 minus 14, which is 5. Now that we know that t is 5, we can substitute it into here. And we say b is equal to 7 minus 5, which means that b is equal to 2. So in the shop, there are 2 bicycles and 5 tricycles. Let's do another one. Adam and Jessica are friends. Adam takes Jessica's maths test paper and will not tell her what her mark is. He knows that Jessica dislikes word problems, so he decides to tease her. Adam says, I have 12 marks more than you, and the sum of both our marks is equal to 148. What are our marks? Let's start by assigning variables to the marks. Let's say that Adam's mark is A and Jessica's mark is J. Adam says, I have 12 marks more than you do. So if J is Jessica, to get to Adam, we have to add 12 marks to Jessica's paper to make it equal to Adam's mark. The sum of both of our marks is equal to 148. The sum tells us we need to add, so we're going to say J plus A is equal to 148. Now that we have 2 equations, we can start solving to find Adam's mark and Jessica's mark. In this equation, A is already the subject. So we're going to leave it like this and take J plus 12 and substitute it in over here. So we say J plus 12 is equal to 148. J plus J is 2J is equal to 148. We're going to move the 12 and we say minus 12. 2J is equal to 148 minus 12 is 136. Now to get J by itself, let's divide both sides by 2. And we see that J is equal to 68. Now that we have Jessica's mark, let's find Adam's mark. We're going to substitute 68 into our J value over here. So we say 68 plus 12 is equal to A. 68 plus 12 is 80. And this is Adam's mark. I want to do one more example. Terry bought 20 shirts at a total cost of $980. If the large shirt cost $50 and the small shirt cost $40, how many shirts of each size did he buy? Let's start by allocating our variables. We have got large shirts and small shirts. So let's call our large shirts L and our small shirts S. The cost of the large shirt is $50. So we can say cost of large shirts is $50 for every large shirt. The cost of the small shirt is $40, which means there will be $40 for every small shirt. Terry bought 20 shirts. So if we take all the large shirts and we add all the small shirts, we'll get a total of 20. The total cost of the shirts was $980. So $50 for every large shirt plus $40 for every small shirt gives us a total cost of $980. And now we have 2 simultaneous equations. Let's start by making L the subject in this equation. So I'm going to say L is equal to 20, move the S, so we say minus S. And now I'm going to substitute 20 minus S into our L over here. So I can say 50 multiplied by, instead of L, I'm going to use 20 minus S plus 40 S is equal to 980. And now I can expand my bracket. 50 multiplied by 20 gives me 1000. 50 multiplied by negative S is negative 50S. Then I add 40S, and it's equal to 980. Now on the left-hand side, I've got 1000. Leave this over here for now. Negative 50 plus 40 gives me negative 10. So I have negative 10S is equal to 980. Now remember, you can have one shirt, you can have 10 shirts, you can have 100 shirts. You can never have a negative amount. So the first thing we need to do now is to move negative 10S to the other side of our equal sign and make it positive. So over here I have 10S. On the left I have 1000. I want to move 980, so I say minus 980. 1000 minus 980 is 20, which is equal to 10S. Divide both sides by 10, and we see that 2 is equal to S. Now that we have two small shirts, let's see how many large shirts Terry bought. So we're going to substitute 2 into our S value over here, and we say L is equal to 20 minus 2, which means that L is equal to 18. And we have now completed this question. You will see more examples like these in our upcoming videos.